Welcome to the course Business Analytics and Text Mining Modeling using Python. So in previous few lectures we have started our discussion on pandas, another important package in the Python platform. So let's pick up from where we stopped in the previous lecture. So we were about to start the interaction mechanism with the data in a series or data frame. So let's pick up from that. So let's take the example of re-indexing here. So for this to perform re-indexing, so as we have understood that in both series and data frame we have 1 and 2 indexes respectively. So if we want to change that, so the few approaches we have discussed before. One is another approach is using re-index method. So let's talk about this. So let's take this example of series 8 where we are initializing or defining this series with the 4 elements, and you can see the index also. So if let me run this. So if we want to re-index this series, you can see series 8 and series 8 dot re-index. So in this fashion we can call this method, and within the parentheses you can see that we can re-specify the new index here. So you can see earlier one we had just the 4 elements in the index when we passed it in the arguments in index. Now we have 5 elements in this index when we are calling re-index method here, A, B, C, D, E. So E is the additional, and also you can see that the order has changed. So now in re-indexing we are using the alphabetical order. So let's run this. So what will happen is that in the new series 9, whatever indexes are matched, so they would be appropriately displayed in the as per the new index. You can see A, B, C, D, E, but for E there was no value element there in the series, so for that NaN is being displayed. So in this fashion we can use re-index method as well to change our indexes. Now as you can understand that while we are re-indexing, as you saw in the previous output 272 that in 272 that any unmatched indices, they might have NaN values. So we have certain methods which can help us in refilling those values. So let's talk about some of these methods. So filling values when re-indexing. So one of these method is ffill method. So how do we use this? So let's take example of this series 10. So in this we have these 3 elements, blue, purple and yellow, and the indexes as well. So if you notice the index argument, we have 3 elements with 0, 2, 4. So you can see that the few indices are missing. So we can always fill these indices using a fill method. So we'll see about that. Let me first define this series 10. You can see 0 to 4 and blue, purple, yellow. So now we can fill this using ffill method. So you can see series 10 dot re-index range 6, and you can see the method name ffill. And if I run this, now you can see the range has also been changed. So range is 6, and because the remaining elements we would be filling up. So if I run this and you have a look at the output, you can compare these two output 274 and 275, and you can see earlier the series 10 had 3 element. Here we have 6 element. The index has been changed. Now we have 6 index values starting from 0 to 5, and the new values they have been filled using ffill method. So you can see for 0 and 1 it is blue, 2 and 3 purple. So this is how the ffill method can be used to fill the values and re-index the series as well. Now let's move forward. Now let's talk about re-indexing with a data frame object. So let's take example of this data frame df4. So here you can see that we have this we have this we are using a range function to generate the values, and the dimensions are 3 cross 3. So first dimension 3 elements, second dimension 3 elements, and index you can see ACD and Delhi, Mumbai, Bangalore. So if I run this, you can have a look at the DF4 data that we have. And if I want to change the index here, you can see the index right now we have ACD. So I can add B also here. So let me use the reindex method here. So we are storing this one also to df5 is equal to df4 dot reindex, and I have specified the the changed index also. So if I run this, we'll get D5. Now if you look at the df5 here, then row with the index value b, all the values are NaN, because the corresponding value elements were not present. Now similarly we can also reindex column as well, the column index as well. So for this we will have to specify the columns argument. So in the method reindex, we will have to use this a keyword argument columns, and then we will have to specify our specific ordering or index that we want. So you can see now we have changed the order and we have made it as alphabetical. So Bangalore comes first, then Delhi and Mumbai. If you look at the output 278, then the ordering is slightly different. So if I run this, you can see the output 279 and the ordering for the column index has changed. Now let's talk about another another way of reindexing. So this is using LOC attribute. So we can have this we can use this LOC attribute df4 dot LOC, and in this we can specify these two indices here in this fashion. You can see it's like row index first and then followed by the column index. So row index we have specified ABCD, and column index Bangalore, Delhi, Mumbai. So whatever we did using the reindex method, we can do the same thing using LOC attribute, but slightly different syntax here. So if I run this, you can have a look at the output here. So the output is same as the previous reindexing that we did using reindex method. However, we are also getting a warning here, that future warning. So in future in this mechanism of dot LOC is not going to be available. So you can see that, you can read the warning. So right now it is working, but in future this support might be taken out. Now let's talk about another aspect here, that is about dropping cases or rows. Sometimes we would like to delete certain columns, certain variables that we might not find relevant, or certain rows for based on our analytics logic we might like to get rid of certain rows. It could be due to missing values as well. So let's take the example of df5. So in this you can see the row with the row index b is having all the NaN values. So we can drop this because of the missing values. So for this we can use the drop method here. So we can call df5 dot drop, and we can pass on the row index here, which is within single quotes we can specify b, and you would see in the output that this particular row is gone. So we can use this method in this fashion to drop certain rows or columns. So similarly we want to drop two rows, multiple rows, then again within we can use a list and we can pass on these row indices there, and the drop method will do the job here. So let me run this, and you can see we are left with just two rows. Now let's talk about the another scenario, dropping columns or variables. So let's take df5 again. So this is df5, and if we want to drop, let's say Bangalore here. Apart from indicating apart from in the first argument passing the value of the indice that we want to drop, that is Bangalore in this case, we also have to specify the axis. So x is equal to 1 to indicate that we want to drop a column which is having this index, column index, as Bangalore. So if I run this, you can see in the output Delhi and Mumbai, these two columns are present, but Bangalore is gone. Let's move forward. So now in this case we are dropping multiple columns here. So we are dropping Delhi and Mumbai, and we will be left with Bangalore, as you can see in the output. Now apart from apart from the drop method, we can also do an in place version of drop method. So for this we have an in place argument there. So let's again take the example of df5, and in the next thing that we are going to do is we are going to drop this row with the b index, and you can see we are using in place argument as true. So, in the D5 DF5 data frame itself, this particular column is going to be dropped. So, D5 data frame is going to be modified. So, this is in place version using the in place argument here. So, if I run this, you can see DF5 and one particular row is gone. Now, let us focus on some other aspects of Python, which is about accessing, selection and filtering. So, let us start with the series. So, let us take the example of the series 11 which we had earlier created. So, here we have these 6 elements blue blue, purple purple and yellow yellow, and let us take another series 7. So, here we had slightly different indices beta, alpha, beta, sigma, and the values 1.1, 1.3 and so on. So, if you want to access one row, as you would expect that series 11 and within brackets we can specify the index here. So, I can say series 11 and I can specify 3. So, in this case it is an integer index. So, I can just specify that, and you can see we have got the purple as output. Now, in case of a string index here series 7, we will have to specify it in within single quotes. So, series 7 within brackets, single quotes and sigma, and we would be able to access the value which is in this case 1.3. Now, if we want to access a range of rows, so for that we can specify using colon operator. So, in this case example series 11 within brackets we are saying 3 to 3 colon 5. So, starting from 3 to stop 0.5. So, 2 rows are going to be displayed in the output here. So, if I run this, you can see row index 3 and row index 4, those rows have been displayed in the output. Now, if we want to select few rows, so that can also be done. So, for this within the brackets operator we can pass on a list of the selected rows that we would like to display. So, for example series 7 and within double brackets we are passing a list again using brackets sigma and alpha. So, we are selecting these 2 rows. So, if I run this, you can see in the output only 2 rows have been displayed. Similarly, for the series 11 also we can do the same thing, where we are using the integer index, row index. So, we are selecting row index 1 and 5. So, if I run, those rows are going to be displayed here. Now, filtering. So, we can have certain logic, and based on that logic we can filter certain number of rows or columns. So, let us take an example in series 7 and we can specify within brackets an expression which is going to return the kind of boolean values. So, that we will be selecting those particular rows only, in a sense we will be performing filtering. So, if we are looking for rows where the series value is less than 1.3. So, we can put that expression within double brackets, and only those rows are going to be displayed. So, if I run this code here, you can see that just one value beta which was less than 1.3 is has been displayed. Let us move forward. Next aspect is slicing. So, slicing is very much similar to like we have discussed in other context. However, in this case end point is inclusive. So, earlier whenever we have used slicing, the end point was non inclusive. So, when we do slicing on series and data frame, so that is inclusive. So, let us say series 7 and within brackets we can pass on like this alpha and then colon and sigma. So, those rows are going to be sliced and displayed. So, if I run this, so you would get that output number 297 starting from alpha, beta and sigma, those 3 rows which were part of the slicing, they have been displayed. However, since in the series 7 we do not have unique index values, rather we have certain rather it can be defined as non unique index. So, in this case the slicing might not work if we happen to select a particular slicing where this non unique indices are involved. So, let us say series 7 beta to sigma. So, if you remember we have 2 betas in this, if you look at the previous output, let me go up and let me go up further. Yes, here output number 290, you can see beta, then alpha, then beta, then sigma. Now here you have 2 betas. So it would be difficult for the Python interpreter to infer which beta we are talking about. So in that case, because of non-unique indexing, this slicing might not work, because the inference is difficult for the Python interpreter. So if we specify series 7 beta colon sigma, then we would, it would not be able to infer which beta we are talking about. So if I run this, we'll run into this error here, and you can see cannot get in the key error, it is cannot get left slice bound for non-unique label beta, because beta is non-unique. Two instances of this the same row index value are present, so it is not able to resolve. Now let's take another example. Next, another slicing series 7 alpha colon sigma. So here you can see this time it worked. So in this case we have done an assignment. So all the all the rows which were part of the slicing, and they will be assigned this value 1.3. So if I check it again, you can see series 7 and those rows starting from alpha to sigma all inclusive. So those have been assigned this value 1.3. Now let's take example of a data frame, and we'll talk about some of these things again. So df5, let's take this particular data frame. Now how do we access a particular column here? So within the double brackets we can specify the column index. So df5 within brackets daily and single quotes. So in this fashion we can access a particular column. We can also access multiple column. We can pass on a list of column indices. So next example, df5 within brackets, they are passing a list Delhi and Bangalore, and we'll get a list of indices here, list of column indices, and therefore those columns are selected in this output, as you can see in the output number 303. Now slicing rows in a data frame. So again within the brackets we can specify, and we can use the colon operator. So for example colon 2, so we did not specify this starting point. So those particular indices are going to be selected. So if I run this, you can see the output, those 2 rows have been selected here. Now let's move forward. Another example df5 1 to 2. So in this case if I run, so you can see that the slicing in this case, the row indexes are actually the string string values AC ACD I think, and however we are using the integer values here. So these are the corresponding numbers, and accordingly we are getting the output here. Similarly, just like we talked about series and filtering certain rows, here also in data frame also we can perform the same thing. So let's say in the Bangalore column we would like to just filter rows which are having values greater than 5. So we can specify like this df5 within brackets df5 Bangalore greater than 5. So in this fashion only those rows which are having this particular column value greater than 5, they are going to be in the output, as you can see, just one row. Working with a Boolean data frame. So if I use a expression like this df5 less than 5, so this will give me a Boolean data frame where all the values, they will indicate whether the value was less than 5 or not using Boolean values true or false. So if I run this, you can see in the output a Boolean data frame is there. Similarly, using this Boolean data frame, we can use this as an as indices. So we can pass on this in the df5 within brackets, and we'll get the output here. So wherever true was present, those values are going to be shown, and wherever false is there, so we'll get NaN. Now we can modify these values also based on Boolean expression. So wherever false was there, we can assign a value 0. So in essence we are refilling the data frame using Boolean expressions. So if I specify df5 within brackets df5 less than 5, so wherever the value was not less than 5, so all those elements are going to be assigned this value of 0. So if I run this, let's have a look at the output, and you can see. So in this case, rather wherever the value was less than 5, wherever the value was true, those values are going to be assigned 0. So, rather it would be that kind of output. Now, let us talk about two important indexing operator LOC and ILOC. Till now we have talked about various approaches for indexing reindexing. However, they might not lead to precise indexing because of the way indexing happens there. So, to achieve a more precise indexing we have these two operators LOC and ILOC. So, LOC is used with the axis labels and ILOC is used with the integer values corresponding to axis labels. So, let us take the example of this data frame DF5 once again, and you can see the syntax here. To use the this operator LOC, we can pass it like DF5 dot LOC, just like an attribute, and within in the brackets we can specify the row and column. So, you can see clearly row A and column daily we can specify. So, we used LOC at operator previously also in an example. So, here in this case you can see how we can access a particular element of a data frame. So, we can specify row and column index, and particular element can be accessed in this fashion. Similarly, we can we can select multiple columns as well. So, let us say in the next example we are picking row A, but two columns Bareilly and Bangalore. So, we are passing that as a list in the column index part. So, you can see those two are there in the output. Similarly, this is another way we want to select multiple rows and multiple columns. You can see the code here, one example here. A and B, these two rows we would like to pick, and Delhi and Bangalore, these two columns. So, if I run this, and you can see the output. However, you can see like before, this time also we have got a future warning, because probably this kind of this kind of access is not going to be allowed in future. Let us move forward. Let us take another example where we are using LOC, and again we are specifying the indices, index values for row and column both. So, if I run for this example, you can see the output again. Now, let us talk about the second operator, that is ILOC. This is the operator where we are using integer values, the corresponding integer values. So, here we can specify a syntax like this. We can use the data frame df5 then dot ILOC to specify that we are going to use integer numbers here, and then within brackets 0 comma 0 0, first 0 is for the row and second one is for the column. So, in this case we would be effectively like accessing one cell, just like in Excel. So, you can see 0 comma 0. If you want to select two columns, so you can see the syntax here, example code example df5 dot ILOC, within brackets in the row index part 0, and for the column index part we are passing a list of two values 0 comma 1. So, therefore, we are selecting two columns here. So, if I run this, you would end up with this kind of result here. Let us take a more slightly more advanced version of this ILOC. So, in this case what we are doing df5 dot ILOC, we are picking two rows and two columns. So, in the row index part we are passing a list of row indices 0 comma 1, and in the column index part we are passing a list of column indices 0 comma 1. So, you can see if I run this, the output, those two rows and columns have been displayed in the output. Now, another example. In this case df5 dot ILOC, so I am just picking 1. So, in this case if I pass on like this, we would be just displaying one row. If we do not specify the column part, then we would be eventually accessing the rows. So, corresponding to the row index 1, the particular row has been displayed in the output. Let us take another example of ILOC here. Slightly more number of rows have been selected. So, if I run this, you can see in the output 2 rows C and D and 3 columns, and you can see ordering has also in a sense we can change the ordering also. So, the way we are accessing, and the output also will indicate that ordering is also changed. Now, we can also perform slicing with using LOC and ILOC operator here. So df5 dot loc, and I can specify like this column C. So all those columns up to this index, and then I'm selecting all those rows up to this row index C, and then column I am selecting daily. So in this fashion slicing can be performed. So if I run this, you can see A and C inclusive, these two rows have been selected, and for the column daily. Let us take another example for slicing with the LOC. So df5 dot LOC, and within brackets we can again we are doing again row slicing here, C colon D. So all those rows are going to be sliced for the column daily. So if I run this, we get that we will get those rows C and D for the particular column daily. And let us take another example. So in this case we are performing both row and column slicing. So in the row side we have the same thing, C colon D, and on the column side we have daily colon Bangalore. So those two those particular columns are going to be selected. So daily colon Bangalore selects all three columns that we have and the two rows C colon D. So if I run this, you can see the output here. We can also perform bare slicing here. So as you would remember from our discussion from the previous lectures, we just indicate colon here, that means bare slicing, all the rows or all the columns are going to be selected. In this particular example, it is happening for the rows side, and then on the column side we are selecting 1 column 2. So just one column Mumbai is going to be selected in this case. Now let us move further. df5, another example of bare slicing. You can see apart from the slicing that we are performing, we can also filter it out. So in this case df5 dot ILOC, bare slicing, and 0 colon 2. So 0 to 2, those columns are going to be selected, and all the rows are going to be selected, and on top of that we are performing this this filtering df5 dot Mumbai not equal to 0. So only the rows where the value is not 0 are going to be should be only those should be displayed. So if I run this, you can see in the output only the row D has has been displayed in the output. Now let us talk about few more points on integer indexing here. So let us take the example of series 11, and next is in this case you can see that here in this case, if you see series 11, if you many values are actually repeating here. So in this case, if I type something like this, series 11 minus 3, so here label based indexing or position based, which indexing is to be used, that inference ambiguity is there. So because of this, this is going to fail here. So because it cannot determine how this minus 3 is to be performed, because if you look at the row index that we have in series 11, it starts with a 0 index. So we have a row index value as 3 also, and now if we start from the end side, that means 5 side, then the value will come out to be different. So therefore that ambiguity is created. So if I run this series 11 minus 3, then will run into an error. So anyway, any kind of code example where certain ambiguity is created, for inference ambiguity is created for the interpreter, so it will run into an error in that case. Now let us take an example of series 7. So in this case, you see that in the row index we have non-unique indices. Now in this case, if I pass on series 7 minus 1, so here you would see that if I run this, it is succeeding here in this case 1.3, because of this inference ambiguity issues. Now next thing that we would like to talk about is the arithmetic between objects with unmatched indexes. So if we apply arithmetic operations on a series or data frames and those objects, so how because of the certain indexes that might not match, how these arithmetic operation will work out or other operation will work out. So we'll talk about those aspects in the next lecture. Let's stop here. Thank you.